Okay, year 10. So last lesson where we did some new content, which was a while ago now, last Wednesday, we looked at using the sine rule to find missing sides in triangles. Today we're going to be using the sine rule to find missing angles. Now, if for any reason you haven't caught up with Wednesday's work, you will need to go back and do that, because if you haven't done Wednesday's work, today's work won't really make much sense. So do that first, but most of you should be fine just to crack on straight away. Okay, year 10. So last lesson we looked at using the sine rule to calculate missing side lengths in triangles. Today we're going to look at using this version of the sine rule to calculate missing angles in triangles. So the top version of the formula is for sides, the bottom version of the formula is for angles. They're just reciprocals of each other, they're written upside down. You will need to know both of those formulas. First example then, we label all our sides up. So sides get labelled with lowercase letters. Angles get labelled with capital letters. And let me think about what we know. So in this case, I know A and A. I know side B, and I want to know angle B. So I'm going to use that version of the formula. So down here, I would write sine A over A equals sine B over B. I then substitute in. Now, we need to make, I'm just going to highlight, we need to make theta the subject. Theta is like x here, it's what we want to work out. We want to work out what theta is. The first thing we need to do is to get rid of this 4.3, so we multiply both sides by 4.3. But we've still not got theta by itself, because now we've got sine theta, and I still want to get theta by itself. So I need to do the opposite, the inverse of sine. Then the inverse of sine is written as sin to the power of sin minus 1, like that. So what I do now is on the left-hand side, I get sin minus 1. And then this entire term comes in here. So 4.3 times sin 73 over 5.2 equals theta. So that was a horrible theta. Let me draw that again. Equals theta. And so now I put all of the left-hand side into my calculator in one go. When I put that into my calculator, I get this. If we read the question again, the question wanted my answer correct to the nearest degree. So to the nearest degree, where it's 52.5, it's 50. Oh no, I've made a mistake with copying it out of my calculator. 1 second. I should actually get that. So it's 52.25. 52.2 is closest to 52 degrees. And so that is my final answer. Okay, year 10. Pause the video now and have a go at the question on the right hand side. So hopefully you've had a go at that. The answer should be 40 degrees. If you have got an answer of 40 degrees, stop watching now and get on with the main task that has been set. If you did not get 40 degrees, or you did not have a go at this question because you were like, what, I don't know what is going on yet, watch and we will go through it together. Okay, so we're just going to re-go through that question from the previous slide. If you've already got the answer, you shouldn't be watching anymore. Now, we begin by labelling up our sides. Our angles have been labelled already. Now this is A, so this is A. This is B, so this is B. And this is C, so this is C. We then think about what we know already. So in this case, I know side C and I want to know angle C, and I know B and B. So I'm going to begin by writing out my formula. Sine B over B equals sine C over C. So then we will get sine 50 over 12 equals sine of theta over 10. First step, remembering, we're aiming to get up to theta by itself. We're aiming to make theta the subject, effectively. So first step is to think, well, how can I get rid of that 10? And the answer is I can multiply both sides by 10, giving now remembering we still want to get to theta being the subject. Theta is not the subject at the moment because this is sine theta. So we do the inverse of sine, which is written as sine -1, like that. So then we do on our left hand side inverse sine, and then big bracket, and then all of this bit here, 10 times sine 50 over 12 equals theta. I need to then put all of this into my calculator. When I do that, shift, sin, 10 times fraction button, sin 50, close brackets, over 12, close the big bracket, I get this. And then remembering we want my answer to the nearest degree as before, so 39.6 rounds up to 40 degrees, and that is the final answer. With that in mind, year 10, copy down all of that example and the previous example into your book if you need to, and then have a go at the main task. If you are stuck or need any help as ever, drop me a message or show my homework or email me.